To analyze a rigid body in equilibrium, we need to draw its free body diagram. A free body diagram is a sketch of an isolated body which shows external forces on the body and reactions exerted on it by removing supports. I have taken an example of a simply supported beam. If you want to draw free body diagram of this beam, you have to sketch this beam first and apply force of 10 kilonewton at 30 degree. Now you have removed this pin joint, so in place of pin joint, show reactions. I have shown two reactions here, and in place of this roller support, remove this roller support and draw one reaction. Hence, to draw free body diagram of a rigid body, you have to sketch that rigid body first. Then you have to show weight always act vertically downward direction. Then you have to show all the external forces or applied forces given in the problem, and then you have to show reactive forces caused by supports or constraints that tend to prevent motion. To understand the reactions caused by supports, we will study some common supports and reactions caused by these supports. First, I have taken a roller support which is shown like this, and sometimes it is shown like this. In this case, roller restricts motion of this body only in a direction perpendicular to the surface. You can therefore to remove this type of supports, you should show only one reaction which will be perpendicular to the surface in which this roller is placed, like this. Similarly, in this case also, you should show one reaction which is perpendicular to this surface. Sometimes roller supports are kept in an inclined plane. Then in that case, you have to show reaction which is perpendicular to the surface. The surface is making an angle theta from horizontal, therefore perpendicular or normal to this surface, this reaction is perpendicular to this surface. This will make same angle theta from vertical. Next support is smooth surfaces. When a block is kept on this smooth surface of weight W, you want to draw free body diagram of this block. First, sketch this block, apply weight vertical downward direction. Now I have removed this support, and in place of this support you should show one reaction which will be perpendicular to the surface. Here I have taken a beam which is supported at two smooth surfaces. Now here at this point there will be one reaction. That reaction will be perpendicular to this surface. Now this surface is making angle alpha, therefore this perpendicular reaction will make same angle alpha from vertical. Similarly, at this point there will be one reaction. This reaction will be perpendicular to this surface, and therefore it will make same angle beta as made by this surface from horizontal. To draw free body diagram of this beam, you have to draw this beam, then apply vertical load, this W, and then remove this surface and show reaction at an angle of alpha, and remove this surface and show this reaction at angle of beta. This is the required free body diagram of this beam. Again, the cases of smooth surface. In this case, a cylinder or a sphere is kept on a smooth surface. In this case also, you should show only one reaction. If you draw free body diagram of this roller, weight is acting vertically downward direction, and at the point of contact, at this point of contact, you should show one reaction. That reaction is perpendicular to the surface. Now this surface is tangent to this circle, therefore this R will be normal to the circle, and we know that all normal will pass through the center of the circle, so this reaction will pass through the center of this circle. Another case I have taken in which two spheres are kept inside a drum. Now you can draw free body diagram of each of these circles separately, or you can draw free body diagram of both spheres together. Let's first draw free body diagram of this sphere. Take out this sphere, or you have to draw this sphere as a circle. Now its weight vertically, it is acting vertically downward direction. Show this weight. Then I have removed this vertical support, so in place of that vertical support I will show one reaction R1. Now there is another support which is given by this another sphere. I have removed this sphere, so you have to show one reaction here at the point of contact, at this point of contact. Now direction of this reaction R2 will be along the line joining the center of these two circles. If you want to draw free body diagram of this bottom one, then you have to draw this circle. Now apply weight first, vertical downward direction. Now there is a contact point between these two, this reaction R2, same reaction. So you have to show R2 here. Now you must remember that this R2, whatever name you have given here, same name you should give here also, and whatever direction you have taken, you have to take opposite to the this direction. So you have taken upward direction, so here you must take downward direction, that is compulsory, and same name you should give to both the reactions because these are action and reaction forces. Now other support is this bottom support. So I have removed this bottom support. So in place of this horizontal surface I have shown this reaction R3, and similarly there is one vertical support. Remove this support and show this reaction R4, and all this reaction will pass through the center of this circle. Now if you want to draw free body diagram of both spheres together, draw these spheres. Now since these two are joined together, they are not get separated, and therefore there will be no force at the contact point. First you show weight of these spheres vertical downward direction. Now at this point, this contact point we have removed, so remove this contact point, and same force, the same R1 you have to show, same name and same direction. Similarly this support you have removed, bottom support, so in place of this you should show R3, and this vertical support also removed, so in place of this vertical support you should show R4. All these forces, all R3 and R4 passing through the center of this sphere, and R1 is passing through center of this sphere. Now if you want to draw free body diagram of this drum, you can draw this drum first. Now one contact point is here, so here you should show one reaction. This reaction is R1. So whatever direction you have taken here, you have to take opposite direction here. So name same R1 but direction is opposite, left side. So here you have to take right side. Now at this contact point you have taken this R3 upward direction. So at same point you should draw R3 in downward direction. Here R4, this contact point R4, you have taken right side. So you should take left side R4 in this direction at the same contact point. In this way you can draw free body diagram of a sphere or a cylinder. Next support I am taking is a pin or hinge support. In case of pin or hinge support, it restricts any linear motion, but it allows to rotate about this pin like this. This pin support is normally represented like this, and in case of pin support there will be two reactions. So whenever there is a pin support, you should remove that support and show two reactions which are perpendicular to each other. You can give any name to these two reactions, but these two reactions must be perpendicular to each other. Now arrowhead you can take upward or downward for Ry. Similarly right side or left side for Rx. Now next support is a fixed support. Now this support does not allow any linear motion as well as any rotational motion. Therefore to draw free body diagram of this beam, you have to draw this beam first, apply external forces. Now in place of this support you have to show three reactions, two force which are perpendicular to each other like this, and one moment because it is not allowing any rotational motion. So there will be three reactions, two force and one moment. Now in case of flexible inextensible string, there will be only one reaction, and in that reaction will be in the direction of string. For example, if you want to draw free body diagram of this weight W, so you have to draw this figure first, then apply weight vertical downward direction, and now because of this string there will be one reaction. This string is supporting this weight, it is not allowing it to fall down. Therefore in place of this string you have to show one reaction, and normally this reaction is represented by T for tension. Now here I have taken one example. A spherical ball is kept in its position by a string like this, and by this vertical wall. So if you want to draw free body diagram of this sphere, you have to draw this sphere first. Now apply weight vertical downward direction. Now there will be one force or one tension along the direction of string. In this direction you have to draw one tension force. So tension, now angle of this string is theta from vertical, so T will also make same angle theta from vertical direction. And similarly there is one vertical wall which is supporting this sphere, so you have removed this wall. So in place of wall you have to show one reaction which will be perpendicular to this wall at this point of contact. So at this contact point you show one reaction which is perpendicular to wall, and this reaction will pass through the center. When a string passes over a frictionless pulley, then each part of the string will have same tension. Here you can see that this string passes over a frictionless pulley, and here in this part we have shown that at this part tension is T, then at this part also tension will be T. So here and here tension will be same if this pulley is frictionless. Now this case I have taken here. Here a one single cord, this is a one single cord which is tied between two vertical wall. Now I have kept one ruler in this string and applied one weight W. If you want to draw free body diagram of this, so you take one point, weight vertical downward direction, this is acting vertical downward direction. So in the direction of string, draw two forces. One is this direction making an angle of alpha, and another one is in this direction making an angle of beta. Now this is a single string and this is a frictionless pulley, therefore tension in both part of the string, this part and this part, will be same. Therefore I have shown same name, I have written same name T and T here, because this and these two tension will be same. A similar case I have drawn here. Here one ring is there, and in this ring one string is connected here and one string is connected here, and a load is applied here. Now in this case this is a ring, and in this ring two different strings are connected. This is a different string and this is a different string. So if you draw free body diagram of this ring, then you will get one load, weight vertical downward direction, and two tensions like this in the same direction, in the direction of this string alpha, angle alpha, and one tension this direction, and another one is this one in this direction T2. These two tensions may be different because these two are different strings. Now this concept can be utilized for the chain, belt, rope, cable, wire, etc. In case of a beam which is loaded only at 2 points, the force on the beam will be in the direction of beam itself. Therefore in this case, when you draw free body diagram of beam, you can show this force as W, this is as tension T, and in place of this pin support you have to show two reactions, but I am showing only one reaction which is acting in the direction of beam itself. So in this case you don't need to draw free body diagram of this beam. Actually in this type of cases we will draw on free body diagram only of a point B, like this. Draw one plus sign, mark that point B and show forces. This is W, and one force is tension T, and another force is FAB, which is acting in the direction of this beam. Another example I have taken, this beam only loaded at 2 points. Therefore if you want to draw free body diagram of this beam, you have to draw this beam, show forces, one weight W, one tension T in direction in angle theta, and in place of this A pin joint you have to show two reactions, but again you will show only one reaction in the direction of beam, only FAB. Again in place of drawing free body diagram of this beam, you should draw free body diagram of B only, like this, and show all the forces. So this FAB I have drawn in the direction of AB, either this side or this side also you can draw. And once you calculate FAB, that will be the reaction at this point A. Now a similar problem I have taken here. Now in this particular case, this beam is loaded at 3 points. One is at A, here pin joint. One point is B, where one load W is acting, and one point is this in between A and B. One string is attached. So one tension force is acting at this beam. So in this case, when you draw free body diagram, you have to draw this AB, full AB, and once you draw this AB, you have to show forces. First is W, then tension at angle theta. Now since this is a pin joint, now you have to show two reactions here, XA and YA, because this beam is loaded at 3 different points. If it is loaded only at 2 points, then you will show only one reaction in the direction of this beam. Now conditions of equilibrium. Once you draw free body diagram, you can apply conditions or equations of equilibrium. For a concurrent coplanar force system, equations of equilibrium are summation of Fx is equal to 0, summation of Fy is equal to 0. And for non-concurrent coplanar force system, equations of equilibrium are summation Fx equal to 0, summation Fy equal to 0, and summation m equal to 0. Therefore, in a concurrent coplanar force system, with these two equations, you can determine any two unknown quantities. And in non-concurrent coplanar force system, with using these three equations, you can determine any 3 unknown quantities. So let us take one example. A sphere of weight 100 Newton is tied to a smooth wall by a string as shown in figure. find the tension T in the string and reaction R of the wall. Here this is a sphere, its weight is given W is equal to 100 Newton and angle theta is given 15 degree. You have to determine tension in this string and reaction R of the wall. Here reaction R. For that you have to draw free body diagram of this sphere first. Draw this circle, weight vertical downward direction, tension T at an angle of theta from vertical, same angle, and reaction R this direction. Now this is all these three forces. R is also passing through the center of the sphere, weight is also passing through the center, and this tension is also passing through the center. So this is a case of concurrent coplanar force system. So you have two equations, summation Fx equal to 0 and summation Fy equal to 0. From these two equations you can determine two unknown quantities, and these two unknown quantities are tension T and reaction R. For this, draw a plus sign, show all these forces, weight W 100, R, and then T. Now to apply sigma Fx equal to 0 and sigma Fy equal to 0, you should resolve this force into two components. So first, horizontal component, draw one vertical line from this point. This will be horizontal component, and value of this horizontal component, since it is making angle from y-axis, so this is opposite side, so this will be sine theta. So this will be T sine theta, and other component, this component in y direction, this is angle theta, so this will be T cos theta. So this will be T cos theta. Once you resolve this force into two components, you cancel out this, cancel this. Now all the forces are along x direction and y direction only. Now apply sigma Fx equal to 0. So in x direction, R positive x, this is minus T sine theta, R minus T sine 15, theta is 15, is equal to 0. From this you are getting first equation, R is equal to T sine 15. Now apply sigma Fy equal to 0, sigma Fy equal to 0. In y direction, T cos theta minus 100. So T cos theta, T cos 15, upward direction positive, downward direction negative, minus 100 is equal to 0. If you simplify this, equal to 100, then T is equal to, you will get 103.52 Newton. Once you get this value of T, put this value of T in equation 1. In equation 1, in place of T, I have written 103.53, and when you simplify this, you will get resulted as 26.8 Newton. In this way, you can draw free body diagram and then apply conditions of equilibrium and determine unknown quantities. Thank you for watching this video.